Hello everyone. Today we are going to solve today's daily Leetcode question, max dot product of subsequence. So now what we need to do here is we are given two different arrays and we need to find the maximum possible dot product of the two arrays. For example, let's start with an example what the question is saying. This is the first array and this is the second array. Let me change the color. So for these two arrays we need to find a dot product. Now dot product is what is it is like a1, a2, a3 dot 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 an. This is the first array and the second array is b1, b2, b3 dot 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 bn. So what is the dot product of these two arrays is we multiply the first element of array 1 and the first element of array 2 plus second element of array 2 into second element of array 2 plus third element of array 3 into third element of array 2 dot 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 till n. Let's see how it is. A1 star b1 plus a2 star b2 plus so on till an star bn. So I have just told this that what is a dot product. Now in this particular question what we are given is two arrays and we need to find the maximum possible dot product in between the subsequences. What is a subsequence? I hope that you know that in this whole array when we delete any element, let's suppose we delete 1 and 5, then the remaining those elements form a subsequence like 2 comma minus 2. Like here if you delete 0 then it becomes 3 comma minus 6, but we need to ensure that we don't change the order of the elements. So here we need to tell the maximum possible dot product. A subsequence, the definition is given, we need to return the maximum dot product. So in this particular example let me rewrite here 2 comma minus 1 plus 1 minus 2 comma 5. This is the array 1 and the array 2 is 3 comma 0 comma minus 6. So what is the maximum possible dot product? We can take any subsequence from array 1, any subsequence from array 2 and this subsequence s1 dot s2. We need to find the maximum dot product from this. So we take the first subsequence from the array 1 as 2 comma minus 2. This is the subsequence 1 and from this array 2 we take 3 comma minus 6 as subsequence. Now what we do is do dot product. So 2 3 are 6 plus multiply this and multiply this. Minus 2 into minus 6 12. So the output must be 18. So that is it, 18. Let's see another example what the question is saying. So here 3 comma minus 2 and 2 comma minus 6 comma 7. So as we can see here, if we multiply 3 and 7 we will get 3 into 7 which is 21, which is the maximum possible dot product. You can check many other subsequences also. So in this way we can see what the question is saying. Now how can we solve this question? First of all, I want you all that whenever we see subsequences, the first thing which must strike in your mind is dynamic programming, DP, because in DP only we see many permutations or many subsequences, many order of subsequences, and we play with these subsequences. So the question is how can we apply DP or how can we think of DP? Now for example, let's see in this particular example, if we say here at the start, let's write here 3 comma minus 2. Here I will just point my index 1 here, and in the second 2 comma minus 6 comma 7 I'll just mark my index 2 here. Now I will just iterate idx1 also, idx2 also, and create many other conditions. Like the case 1 can be I will just increment index 1 plus plus, or the second case could be I can just increment idx2 plus plus, or third case could be I will take that element, that idx1 comma idx2, take that idx1 comma idx2 and then increment both. Okay, we will just increment both plus plus. So in this way we can form various possible cases so that we can just find which is the most optimal solution. So let me just help you with the recursion code, then we will just delve into DP and other optimizations. Okay, so here first of all what are we given? Okay, first start here, let me write nums1 dot size, which is my n1. Okay, don't worry, I will just explain you how we are coding. So nums2 dot size. Now we will just create a solve function, nums1, nums2, idx1, idx2, and then we will just here we'll just return this, right? First of all, I am writing the recursion code. Okay, recursion code void solve. Now just copy and paste this first of all. idx1, idx2. Now first of all, let me explain you. Suppose I am just iterating over this whole array. Suppose I reach here, idx1 reaches here at index equals to n1. n1 is the size of the first array. When the index 1 reaches the end of the array 1, what should we return? Should we return 0? Can we return 0? Suppose if the subsequence, like here, suppose the example is okay, I have not taken, let's see here. Suppose in this particular case the answer is coming -1, negative. So suppose if you return 0, in this particular case when idx1 is equals to n1, then you can't return 0 because our answer can also be negative. Since our answer can also be negative, you can't return 0. You need to return int underscore min. Okay, now let's see how we will be doing so. If idx1 is equals to nums1 dot size, or it can also be possible that idx2 can also be equal to n, right? n2, like here my idx2 can also reach here at the n2 part. When I am iterating on my index 2, then it can also reach to n2. So at this point of time, can also return int underscore minimum, nums2 dot size, return int underscore minimum. Now the issue is you can't just return int underscore minimum, because if by chance in your recursion code later on, if you add or subtract anything, then it might overflow the result. So that's why I will just return by 2. It is just for the sake of security and convenience, nothing else. Now here, suppose I have an arrays, draw a1, a2, a3, a4, a5 ... an. Now suppose you are at this position. Now you have two options. Either you start your subsequences from here, a3, a4 ... So what your sequence, what your recursion will look like, idx1 plus 1 comma idx2 plus 1. It means you have, this means you have taken this part, you have considered this part in your recursion. So that's why you are doing idx plus 1 or idx plus 2, or you are starting a recursion from here, or there's another option that you use this part also in your recursion part. Like what I am saying is a1, a2, a3, a4. What is possible is either you use this part of the use the subsequence from this part and add into your result and then continue on adding, or there is also a chance that you won't get an optimal result from this part, so you start from this position, because it is not given that we can start our subsequence from any point of index, any index from here or here. We can start like here. If you see, we can start from either 2 or we can start our subsequence from 1. It is not necessary that we take all the indexes from the array 1. So that's why, what if I just don't take this part, I just start my whole subsequence from here. So my recursion will look like solve idx1 plus 1 comma idx2 plus 1. I will start from here and plus I will need to add this like nums of idx1 star nums of idx2. It would look like this. So what we need to do next is we will write the code for that. Suppose there are two options. First of all, there are two options when you are taking an element, and there are two options when skipping. Skipping part is very easy, I will explain it. The trickiest part is the two options only. Int take, what is take is equals to, you take the maximum of, either you take this, means either you start your new subsequence from this point of time, or I can just take product is equals to nums of 1 of idx1 star nums2 of idx2. Okay, now there are two options, either you take this product or you start a new subsequence. Either you start a new subsequence or you continue on taking the subsequence from previous also. So you do product plus solve of nums1 nums2 idx1 plus 1 idx2 plus 1. This is your case 1. Okay, now there will be another case. What will be the another case? What if so it was b1 b2 b3 b4 b5 dot 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 bn. Suppose your idx1 is here, idx1, and your idx2 is here. What if a2 into b2, a2 multiplied by b2 is not an optimal case which should be added? So what I will do is, either I can increment idx1 or I can increment idx2. I can't increment both of these together, otherwise I need to add this part in my result. Okay, so I will just increment, I will increment idx1 to here, idx1, or I would have just incremented idx2 from here to here. So I think you are understanding my point is, I can either do idx1 plus 1 and keep my idx2 constant, or I will just keep my idx1 constant and increment my idx2 by 1. So both of these cases are correct, and you might be thinking that where is it idx1 plus 1 idx2 plus 1, that I have already written in here. What is it here? Okay, so let me write the skip case also. Skip 1 is equals to, I'm just skipping the nums1, so it would be solve nums1 comma nums2 comma idx plus 1 comma idx2, or I will just remove here plus 1 and increment here. So this is the case. Now what would be the output? It will just return. Now there are 3 cases if you see total: take, skip 1, skip 2. Like here 4 cases: case 1, case 2, case 3, case 4. Case 1 is what? You start creating a new subsequence from that particular idx1 comma idx2. You start creating a new subsequence from that particular idx1 comma idx2, or you don't start creating, you just continue your subsequence. You just take on this part, plus from here you continue your recursion as solve idx1 plus 1 comma idx2 plus 1. Like here I have seen product, I have just continued my recursion from previous parts and added this recursion, or you just started a new subsequence. Okay, so let me write here for a clearance: either start a new subsequence or just continue your subsequence. Simple. Just see the spelling. Then I will just return my max of take comma skip 1 skip 2. Okay, it must run properly. Let's see. Okay, and it's end. Returns all idx1. Okay, it is 0. We are starting from the 0 0 and going till, we just start from 0 0 and go till n comma n. It is like n1 comma n2, right? Okay, so this is our recursion code and it worked. Now the issue is, how can we optimize this code? Because if I submit this code, it would just give us TLE, we all know, because this whole is recursion part and it is TLE. How can we just optimize this code? The solution is, yes, you know it, it is DP. How can we optimize this part. If you see in our code here, we know that our whole code depends on two major states, IDX1 and IDX2. So in our DP, it's simple. We will just use two states, IDX1 comma IDX2. How can we just write its code? We will create a DP vector and then 2D vector of DP named, and then we will just use both of these IDX1 and IDX2 and just store them. Let's see, vector int DP, and let's do n1 plus 1 for security reasons, n2 plus 1 comma minus 1 DP. Okay, now let's copy that and then just if DP of IDX1 IDX2 is not equals to minus 1, just return it DP of IDX1 IDX2, and then just I will just copy it, copy, and I think so it must work. Let's see. Okay, this is not a recursion code, it is a memoization code. Let's see, enter, and let's see if this code runs fine. Okay, so it worked fine, but if you see, it is just 21.60 and 43 milliseconds runtime. This code is not that optimal. Why so it is not that optimal? Because there are three things in a DP question. First, recursion, normal recursion, in which we just create a recursion tree. We go through all the states one by one, go, then again come back, then again solve, and then we again go. Like, it is very lengthy and it might give TLE. It gives TLE, recursion code. So what we do in a memoization code, we store our states in a DP table. Like, we pre-compute our values so that we don't compute the same values again and again. So that's what memoization is. Then the third thing comes is tabulation. Now, how does tabulation works is, we just remove the recursion stack space. That is like space optimization, we can say. So we remove recursion stack space. Now, tabulation is also easy, but just the thing is, like, recursion or memoization goes from top to bottom, but tabulation goes from bottom to top. It is like bottom up or top down or bottom up approach. Top down approach is recursion, or we can say memoization, and bottom up approach is what it is, tabulation. Okay, so how can we just write the code? It is very simple. We'll just -1 to 0, and then we know that. Okay, one thing is, in our recursion we go from 0 to n comma n, like I have written here. In this tabulation code, the whole thing reverses and we go from here to here, n1 comma n2 to 0 comma 0. Just remove it. Now I will explain you step by step how can we just convert this recursion code into a memoization code into a tabulation code. First of all, see the base case. We will write the base case. Okay, it's very easy. You will just go from you must see at IDX1 equals to num1 dot size, and IDX2, any value of IDX2, it will be int min upon 2. At IDX2 equals to num2 dot size, comma, at IDX1 equals to anything, the value of DP will be int min by 2. So we will do is int I equals to 0, I less than n1, I plus plus DP of I index 1 IDX2 is equals to int min by 2. Okay, let's just the same thing we will do is for n2 DP of IDX2 and I int min by 2. It would be IDX1. Okay, it would be IDX1. So now you have initialized your DP. After the initialization part of the DP, what we need to do is, now everything is easy, I'm telling you. Just remove this part. We have used this part. Just copy and paste this. Just copy and this. Don't think anything. Just cut. Now what I told you, we will go from n1 to 0 and n2 to 0. So we'll just write two loops, and idx1 is equals to n2 minus 1, n2 minus 1. Why n2 minus 1? Because for n2 you have already written it, right? So n2 idx1 greater than equals to 0, idx1 minus minus for int idx2 is equals to okay, sorry, it is n1 minus 1, and then it is n2 minus 1 idx2 greater than equals to 0, idx2 minus minus. Now I just cut the code here and I will just paste the code here. Now we will keep everything same. Just remove solve function and just put in dp idx1 plus 1 idx2 plus 1 plus 1. So dp of idx1 plus 1 and idx2 plus 1. Similarly here idx1 plus 1 comma idx2 dp of 1 idx2, then dp of idx1 comma idx2 plus 1. Okay, now just one more thing. Okay, so everything is written. We have written the three cases: take, skip and not skip. At last we have to write this part: command x, command v, simple as it is, no rocket science. At last we will return. From here we went from n1 comma n2 to 0 comma 0, so just return dp of 0 comma 0. That's it. Remove this part. Now this is what tabulation code. I think so that it must work fine. Let's see. Okay, user undeclared. Okay. It is not idx2, it is n2 basically. It is not idx1, it is n1 basically, right? Because we are just in the base case when it is n1. When idx1 is equals to n1, then our output, what we did in our recursion code, was return int min by 2. Okay, let's submit it and check. It must work fine. So yes, it worked fine. I hope so that you liked the solution, and I think so that you might guys have a type of issue in this part, that when we were writing the recursion code a5 dot dot dot, and when it was b1 comma b2 b3 b4, I'm just taking a long array, so we had options. I'm just revising the code. I think so that you might have an issue or doubt. So when we were at idx1 idx2, what options did we have? Either we increment idx1, okay, case 1 is done. Either we increment idx2, case 2 is done. Now case 3, which was the case 3, we increment idx1, we just continue our subsequences, like we just take this subsequence and add current subsequence. Like my solution, my recursion code would be then either I take sol of id plus 1 comma id plus 2 plus I will just say what did I store yesterday, like previously. It would be product 1. It was a variable which I stored, which is nums1 idx1 into nums2 idx2. Okay, now another thing is, what is the second case? The second case would be we start a subsequence from this point only, id1 comma id2. We start a subsequence from that point only, so it would be nums1 id1 into nums2 id2. So that's why in our recursion code we did as answer equals to max of product comma product plus sol id1 plus 1 comma id2 plus 1. Okay, so these are the two cases. This is cases for what? When create a new subsequence. Okay, it is very important. We are creating a new subsequence, and this part is for what? We are continuing our subsequence. We are like extending our current subsequence. Okay, so I hope so that these 4 cases, 1 case, 2 case, 3 case and 4 case, you understood, and if you have any kind of doubt, just drop a comment. I will explain it. Thank you.